Leaving behind our blue Earth and the Moon, we have ventured 40 million kilometers further. See the Sun, glowing bright and fiery, 110 million kilometers away. Between our world and the Sun lies a land where doomsday strikes every day. Here, the sun rises in the west. This is Venus, Earth's twin. But how much of a twin? Earth is like a paradise, blue, beautiful, full of plants, and alive with human love and laughter. But Venus, oh my God, the heat on Venus exceeds even the hottest volcanoes. The surface of Venus is ablaze with constant fires, while the clouds rain down acid. Here, sulfuric acid rains relentlessly. But how do we know all this? How do we gather information about a planet millions of miles from Earth? Is Venus, the goddess of love of Roman mythology, the evening star we call it, a place where humans could live? Is there life on Venus? Which celestial body could be burned to a crisp for being closest to the sun? And yet it has seas of ice on its surface. How and why could that be? In this series, you will uncover all of these mysteries. Venus is the brightest planet in the sky before dawn and after dusk, as seen from Earth. Though Venus isn't the largest planet in the solar system, why does it appear the brightest of all? One reason is its proximity to Earth. The second reason is the dense clouds of gas surrounding Venus. These clouds are so thick that they reflect 70% of the sunlight that hits them. This is why Venus shines so brightly, second only to the Moon in the sky. When night falls, Venus gives hope for a brighter morning to the hopeful. This planet is enchanting from the outside, but equally terrifying on the inside. A thick, 250-kilometer layer of dense gases envelops Venus. A horrifying sight emerges if one descends through these clouds of gas. God forbid, any image of hell can only be imagined on Venus if one dares to picture it on Earth. The surface of Venus is constantly erupting with lava. Just as we have forests on Earth, Venus has jungles of volcanoes. But they are not merely volcanoes. Acid storms rage through Venus continuously. Sulfuric acid pours down, as if the clouds are exploding during a violent monsoon on Earth. Considering the volcanoes and acid rains, listen further. The winds on Venus rage at speeds of hundreds of kilometers per hour. On Earth, we categorize storms as hurricanes 1 through 5, according to intensity. Hurricane 5 is the most powerful storm on Earth. It can tear down trees, rip off roofs, and make an area uninhabitable. On Venus, the storms rage at speeds of 360 kilometers per hour. Acid rains, furious storms, and a thick 250-kilometer layer of clouds form the first impression of this goddess of love. Living on Earth, we once adored this goddess with all our hearts. Now, Venus asks us, do you still need an introduction? I'm the same one you once loved. No one can live on this dreadful planet, where life is impossible for two reasons. First, the atmospheric pressure on Venus is far greater than that of Earth, due to the 250-kilometer thick gas layer. On Earth, the pressure is 14.7 pounds per square inch. On Venus, it's 1,300 pounds per square inch. That's 90 times more pressure on Venus than on our blue planet. The pressure is so intense that even a strong vehicle would be crushed, let alone a human. Thus, life as we know it cannot exist on Venus. Perhaps the only forms of life that could exist are simple organisms, unicellular life, algae, bacteria, or even mycoplasma, but nothing more complex. There is another reason why life cannot exist on Venus. A key requirement for life is the presence of water and oxygen. The amount of oxygen in Venus's atmosphere is negligible, while carbon dioxide, a life-destroying gas, makes up 96% of it. To grasp how dreadful this combination is, consider Earth's atmosphere. It contains 78% nitrogen, 21% oxygen, and only 0.1% carbon dioxide, less than 1%. This balance is what makes life on Earth possible. On Venus, the equation is the complete opposite. Venus also lacks flowing water, another critical condition for life. Given this, trying to find life on Venus is akin to living in a fool's paradise. What is this? Granite exists on Venus, and granite doesn't form without water, and a large amount of it, like the water in seas. Could this point to the presence of seas on Venus in the past? The answer is yes, as Venus was once very similar to Earth. Billions of years ago, when our solar system formed, Earth and Venus were alike. Both had seas with surging tides, so they were not too different. But over time, Venus drifted closer to the Sun, which caused its temperature to rise accordingly. As a result, the atmosphere surrounding Venus became thick and dense, turning the planet into a hellish place. While sunlight still enters Venus's atmosphere, it doesn't reflect back. Instead, Venus continued to absorb heat for millions of years, causing its temperature to soar to unimaginably high levels. The temperature on Venus has reached 471 degrees Celsius, and in some areas it's even higher than 472 degrees Celsius. So, the intense atmospheric pressure, acidic rains, fierce storms, and countless active volcanoes have proven that Venus is completely unsuitable for human life. Look at the burnt and compressed iron structure on the surface of Venus. That's the remnant of Venera 3. 3 years before humans landed on the Moon, Russia launched the Venera program in 1966 to study Venus. Venera 3, part of the program, landed on Venus on March 1st, 1966. More precisely, it fell on Venus. It was a failed landing. This was an unmanned mission, meaning no one was aboard. The Venera 3 was destroyed by the extreme heat and pressure as soon as it touched the surface of Venus. The mission failed to send any information or data back to Earth. Yet, the debris of this historic first mission remains on Venus today. The Venera spacecraft also bears the imprint of a Soviet stamp, the hammer and sickle. Though the mission failed to conduct any experiments, it remains the first human-made object to reach Venus. Russia later sent Venera 4, 5, and 6 to Venus, but they also failed. Russia kept refining its spacecraft, overcoming each failure in preparation for the next mission. That's why the harsh conditions of Venus didn't destroy Venera 7 immediately. This probe, Venera 7, lasted 23 minutes on the surface and sent back signals to Earth. After that, Venera 8 and 9 were sent to Venus. Though Venera 8 disappeared after 53 minutes in the thick clouds, it still delivered valuable data about the planet, a major achievement in space science. The picture you see is the first ever taken from the surface of Venus. This photo was sent back to Earth by Venera 9, and this first color image was sent back by Venera 13 in 1985. To date, Russia, America, and Japan have collectively sent 40 spacecraft to Venus. These missions have produced mixed results, but it was NASA's Pioneer mission that created a map of Venus. Launched in 1978, Pioneer wasn't designed to land on Venus. Instead, it orbited the planet, taking pictures and sending them to Earth. Pioneer worked remarkably well for 12 years. The mission revealed a mountain on Venus taller than Mount Everest and trenches deeper than the Grand Canyon. The Pioneer Venus orbiter ended its mission in 1992 and quietly retired by plunging into Venus's atmosphere. Just stop and think for a moment. How do these machines send signals back to Earth from millions of kilometers away? It's similar to how we operate a TV with a remote control. The main difference is the distance. A remote sends signals over short distances, while the signals from spacecraft travel across millions of miles. Spacecraft that land on the Moon or other planets are equipped with antennas. These antennas transmit radio signals to Earth. On Earth, large radio antennas receive these signals and forward them to space laboratories. These labs are equipped with systems that decode these signals, which are in binary code, made up of 2 digits, 0 and 1. This method is the same as the technology behind computers and smartphones. Thanks to this process, we receive information from the Moon, Mars, and hundreds of other locations in space where mankind has sent probes or research missions. But there's an interesting problem here. Since Earth is constantly rotating, a receiver on the planet will change direction every 12 hours. So, the question arises, how can it still catch the signals from the other side? The solution is installing a network of antennas that relay the signals to one another. These antennas are all connected, ensuring the signals are never lost. Likewise, planets where spacecraft or probes land are also in motion. How do these machines transmit signals when the planet moves to the other side? The answer is simple. Satellites continue to orbit the Moon or the planet where the probe has been sent. These satellites catch the signals from the machines and send them back to Earth. The signals are received by powerful antennas or receivers on Earth. This whole process is called the Deep Space Network, DSN. This system is so advanced that it can detect signals 20 billion times weaker than normal ones. Thanks to this technology, man has sent research missions billions of kilometers into space. It's truly remarkable. But before we dive deeper into this, let's focus on a fascinating scene: the sun rising in the west on Venus. According to ancient tales, before the end of the world, the sun will rise in the west. By that logic, Venus experiences doomsday every day, because on Venus, the sun always rises in the west. A question likely crosses your mind. The sun rises in the east. So how can a planet where the sun always rises in the same direction be called to rise in the west? If you observe from the perspective of the North Star, all planets in the solar system appear to move in an anti-clockwise direction. This means that the east and west are the same for all planets. However, Venus is the only planet that rotates clockwise on its axis. As a result, Venus operates under a completely different system compared to the other planets in the solar system. So, on Venus, the sun rises in the west and sets in the east, unlike Earth and the other planets. Venus's rotation is not only backwards, but also extremely slow. So slow, in fact, that a day on Venus equals 243 Earth days. This means that while Venus completes one full rotation on its axis, Earth completes 243 rotations in the same time frame. What's even more interesting is that a year on Venus is shorter than a day on Earth. Curious, isn't it? While Venus takes 225 Earth days to orbit the Sun, its day lasts 243 Earth days. If you were to live on Venus, you'd likely celebrate your birthday twice a day. But before we age too quickly on Venus, let's move ahead. Why is Mercury's sky black? Why does it have no atmosphere to scatter light, unlike Earth? Why is the surface of Mercury so hot during the day and freezing at night? What makes this closest planet to the Sun so unique? All of these intriguing questions and more will be explored in the next video, where we'll uncover the mysteries of Mercury and the wonders of our solar system. Stay tuned as we answer everything that has sparked your curiosity.